Good evening. My name is Richard Krutop. I'll be going over the MILSTAR failure, and I labeled this one the unacceptable disaster, unacceptable failure. Slide. So a little bit background about the MILSTAR. MILSTAR is called the Military Strategic and Tactical Relay. That's what MILSTAR is abbreviated. MILSTAR provides a strategic communication for all U.S. government leadership. Some of the U.S. government leadership range from the President, Secretary of Defense, and different U.S. United States Armed Forces. This is basically the backbone for the U.S. to do worldwide communications with both DoD, U.S. government, and other agencies. Now, the U.S. MILSTAR was going to be located at GeoSat, and it would provide that 24/7 coverage for each portion of the globe. The constellation would consist of 6 different satellites and 6 different AORs, and some of those AORs consisted of Eurocom, U.S. NORCOM, U.S. NATO Pacific Command, etc. Um, Again, the constellation would provide communication between ships, submarines, land bases for all different services like the Navy, the Army, the Air Force, etc. And the MILSTAR constellation was going to be worth over $6 billion. Fast forward to present day, MILSTAR was a successful constellation, and it was continued with the advanced extremely high frequency satellite constellation AEHF, and that constellation has already been completed, but MILSTAR was the precursor to that and provided that global communication for any personnel that needed that type of communications. Now, MILSTAR was divided between different blocks. The first block had 2 different flights. Flight number 1 consisted of both uh, each MILSTAR had 2 payloads. One payload had a low rate. For the block 1, had a low rate payload, and on the other side, it had a classified. For the first flight for MILSTAR Block 1, that classified payload was scrapped and was flown on the flight 1, even though it did not work. The second time they launched the MILSTAR Block 1, Flight 2, they launched also the low data rate payload, but they placed a aluminum container so that the spacecraft could have the same center of mass and characteristics as the previous one. Now, the low data rate payload had the ability to transmit 75 to 24,000 bits per second, and that was one of the key factors of the experimental missions. Now, when we get to MILSTAR Block 2, or the MILSTAR 2 failure mission, that was actually a hybrid between the MILSTAR Block 1 and MILSTAR Block 2. What made it a hybrid was MILSTAR. Um, it had MILSTAR Block 1 subsystems, while it had both the MILSTAR Block 2 payloads, which had both the low data rate and the medium data rate payload. Now, the medium data rate payload was a new payload for the constellation, and it would increase the bits per second that would be transmitted from one section of the globe to the next at 4,800 bits per second to 1.544 megabits per second. Now, as I stated before, each each, each of these spacecrafts ranged from 700 to $1 billion to push up. So it was a very expensive satellite to lose, and it was very vital that we had successful missions. failure rate should have been 100% for an ACAT-1 system, which if you are in acquisitions, this is your highest category of programs that you fund at. So, for example, the F-22 was an ACAT-1 system. F-35 was an ACAT-1 system because they are high value dollars programs that cost a lot to design, develop, and then if you have the program fail, that usually means you have wasted a lot of the taxpayers' money. So even one of these spacecrafts, if they didn't make it into orbit, would have been a very big uh, failure for any organization. And since the Space Force uh, is such a small, well, at that point it was the Air Force Space Command, and at that point it was a one-off from the Air Force. I don't want to go to the point of saying they were the best or they were the stepchild of the Air Force, but they received, they divided up the money as best they could. But when Air Force divides up money, usually they look out for their air breathing systems more so than their space systems. But the Space Force knows that these systems give global service to not just the Air Force or the Space Force, but to all DoD partners. So when they look to get out year funding for some of these programs, they need to think bigger picture about Space Force. And that is another reason why the Space Force eventually uh, became its own brand, because it's such an important aspect to the architecture of the DoD and the military mindset. So getting into the MILSTAR 2 failure. Now, leading up to the MILSTAR 2 failure, there had been already two different failures. One was a NRO mission, Mercury, and if you know anything about the NRO is National Reconnaissance Organization, and they provide reconnaissance satellites, and usually they are very, very expensive satellites. We're talking another billion to ACAT-1 system program office, so another very expensive program. So the next program, which was almost 6 or 7 months later, was the Defense Support Program, which was another high valued program. As you can see, leading up to the failure, these two programs were very, very expensive. Going into why we were using the Titan at one of the aspects of Titan 4 was that we were looking for a launch vehicle that would replace some of our aging launch vehicles, and Titan program came out of that. And the Titan program came out of also from the 1986 Challenger disaster. From that, the Challenger was a space shuttle that we were trying to use to get spacecraft into orbit. After that disaster, that was another driver to get the Titan program situated. But the problem with the Titan program was they were running up costs, and there was a lot of delays, and we weren't getting the most bang for our buck. Also, the Titan was designed not as a launch vehicle, but as an intercontinental ballistic missile. So the Space Force was using a missile to put a spacecraft on top, and not saying that all the safeguards were put in place, but to me, it seems like you're building a bullet and you're trying to exit. You're building a system that wasn't built to execute a different mission. So the mission for the ICBM was to fire, to a different country and then deliver whatever nuclear warhead to that country. His other mission was fire, deploy a upper stage, and then the upper stage pushes the craft to the next orbit, usually GEO for most of these high value spacecraft, and then that upper stage releases the spacecraft. So it is a little more intricate to do that type of mission. So for me, the Titan IV wasn't built to launch spacecraft, but was built to deliver nuclear warheads to different countries. So going into the MILSTAR failure 2, MILSTAR 2 was launched on, again, a Titan IV. It was launched on May 1st, 1990. Nothing happened on the first stage. Everything was nominal. But during that upper stage, they had misfires 3 times, had not the correct timing, and had different durations that could have got it to the particular mission. They tried to separate it, or it separated at lower orbit. The mission operators took over, tried to salvage the mission, tried to get the spacecraft into the proper orbit, but it could not. It did not have enough fuel to get it to that orbit. Later on, they found out the root cause was that software had some database errors. There was attitude control loss, and again, the insertion burns were incorrect and didn't perform according to plan. So mitigation steps. So some of the mitigation steps that came from the MILSTAR 2 disaster was the independent review teams that were stood up for different government agencies like NRO, and then NASA, and then also now Space Force. Another thing was they reviewed what it needed. They created a more robust review process, and then finally created a new acquisition strategy for the launch vehicles. So for the independent review teams, the primary mission was only to perform risk assessments on technical risk. For programs, offices, usually you do some type of risk assessment, but usually technical risks are looked at both technical side, cost side, performance side, and by looking at all those, you determine what is the best mitigation step. But for this independent review team, all they cared about was what technical risk would do to the mission. Is it mission failure? What's the probability? And how do you mitigate this risk? Is it mitigated not by cost or schedule, but by actual fix? And the only way to mitigate it, or the only way to mitigate most of these technical risks, is by finding the root cause and fixing it. So most of these independent ratings review teams were inserted both in Space Missile Command, now Space System Command, and also NRO and NASA. These teams were injected into both the spacecraft and launch vehicles. They provided another layer of assurance for the Portfolio Execution Officer, which is the Space and Missile Center Command General, and he's usually a 3-star at that level. So it was very important that the general or commander of SMC had this team injected, not only looking at the risk from a different point of view, but also looking at not having influence from contractors or cost or schedule. These teams also had the same authority going into some of these reviews as a go or no go decision makers. Now, some people would think these personnel should not have these authorities, but it is very important to have these checks and balances and independent ideas to look at the problem at a different aspect and not be influenced by being too closely involved with the mission, also too closely involved with working with the vendor. Some of these teams are made up of different engineers from different technical backgrounds, from propulsion to electronics to whatever it took to solve the problem. And again, they were inserted into all the different program offices that develop spacecraft and launch vehicles inside Space and Missiles. Another mitigation step was to create a more robust review process. So when spacecraft are going through this new review process, they would have to go through a consent to ship, consent to fuel, and also flight readiness review. Now, launch vehicles would also go through some of the same reviews, but in the end, the final review is the most important for the launch vehicle, while the first two are the most important for the spacecraft. So you do not ship a spacecraft to the launch facility for processing unless it is ready to go. You've presented all the risks to the commanding officer responsible for these, and he understands what risks he's going to take sending these spacecrafts into orbit with whatever malfunctions or errors that could ensue of a bad component. Now, for launch vehicles, you have a little bit more time, but for the launch vehicles, it is also a production task and not so much a design and develop. Most of these launch vehicles have been put together 1,000 times for similar missions. So most of the components have been reviewed over and over again. So when they are finally integrated, that is when you find out if there is any risk involved. And at the flight readiness review, that is where the commander or everyone says, hey, there is a go or no go for this launch. And in the end, if there is no go, then you are taking that spacecraft off the launch vehicle and you're fixing whatever component needs to be fixed on that launch vehicle. For example, true life story. One time there was some components on the first stage of the Atlas V rocket that need to be fixed. We took the spacecraft off the launch vehicle, and because I was part of Launch Enterprise at one point, and we had about a 2-month fix, so that mission got delayed for 2 months to get that component fixed, first stage engine fixed. Finally, we had the acquisition strategy. So Space and Missile Command created a different acquisition strategy. It was a 2-phase approach. Now it is a 3-phase approach. The first stage was to carry 4 different companies in the industry and see which companies could make it and offer a bid up to the second stage. The first phase was more for seeing what companies could develop, and some of the costs that would be ensued to develop those. Um, going going into the phase two, though, only 3 of those companies out of the 4 were able to bid and had a viable solution. So the 4 companies that were given money to develop in the first phase were SpaceX, Northrop, Blue Origin, and ULA. In the second stage, only Blue Origin, ULA, and SpaceX had a viable solution at that point. And the Space Force down selected to 2 launch vehicles, launch providers, and those launch providers have demonstrated over the years to be superior to the third and even fourth vendor that the Space Force gave money to, and they were SpaceX and Blue Origin, or SpaceX and ULA. Now there is a phase 3. Phase 3 is another recompete, but they are giving more latitude in the phase 3 by having 2 different lanes. The first lane is a more R&D program, only has to get to one or a couple different orbits, while the phase 2 or the phase 3 lane 2 is a more lengthy contract. So phase 3, lane 1 is only 1 year at a time, while phase 3, lane 2 is a 4-year, but they have more strict requirements gained 2 different orbits. So, in conclusion, we had a problem with our launch enterprise and getting very expensive assets into orbit, and we fixed it by having by inserting a independent review team, also building a more robust review program, and finally building a more competitive acquisition strategy that allowed the development of 2 very reliable and dependable systems like SpaceX and ULA's rockets. Well, thank you for allowing me to share my presentation on the MILSTAR to failure.